Okay. Good afternoon and welcome to today's session of the CERIAS Security Seminar from Purdue University. Our speaker today is E.J. Jones. E.J. is a technical fellow in information security at Boeing Corporation.
Hi, good afternoon. How are you doing? I'm E.J. Jones, and I'm going to talk to you about securing software, securing systems in particular. And so I know some of you are in the computer science and the information assurance and security areas. And so what I wanted to talk to you about is how you go about and best practices in order to secure systems. And so I'm going to cover a bunch of different areas that you may have heard of or you may have covered in classes, and other areas that you probably are not covering in classes. And what I'm trying to do is I'm trying to give you the information or some practical steps to take what you understand and look at areas that when you start working in a real job or so forth, that will be additional steps that are necessary. And you'll see that more in the subsequent slides. Now, if you don't ask questions, then I'm going to think you're really bored, or I'm going to think that the information isn't at the right level. So we're going to go, it'll be really fast talk if you don't ask a lot of questions, or if you don't answer my questions. So what I'm trying to do is trying to get a little more interaction than just me sitting up here like a guest lecturer, okay? Because I'm really here to get your feedback on some of the ideas that I'm going to present. So this is just your basic understanding of what happens for vulnerabilities within software. So you find everybody knows about security flaws in software, and you read about security flaws in systems every day. It seems like there's an exploit being written for software. It costs a lot of money to fix those vulnerabilities. And so in this chart is just from NIST, and says it takes 30 times more effort to fix a vulnerability once the vulnerability is in production. Now, what does that really mean? It means the last figure I heard was like $7.3 million estimated for your average security breach. That's a lot of money. And using the right practices early on in the development life cycle, you can save your company a lot of time and so forth in fixing those type of vulnerabilities. So going on further with the need for secure development, you can see some of the quotes up here. The first one from Jeff Williams: "We'll never hack our way to secure software. It's going to take a culture change." And so part of what I'm up here is I'm going to demonstrate some of the things that are going to take that culture change. We're not going to hack our way. Now, when I meet a lot of people that are in information security or want to be in information assurance, what's the first thing that they think of? I want to learn how to hack a computer, right? Does anybody know how to hack a computer? Okay, dead silence. Good. Well, what I get in my office is, EJ, how do I learn to hack the computer? And so hacking is learning how to pen test and so forth is an important task, but it's one part of it. Earlier, the previous slide, you saw different phases. Where did testing show up? Down in the line after implementation, design, and requirements, and so forth. The next one is from Wired Magazine. A good quote from Wired Magazine, and the next one is from a gentleman from Motorola Solutions. Do you need antivirus? And so he goes on to talk a little bit more about what antivirus is. So there is a need for secure software, but for some reason, security in the development lifecycle is needed. Microsoft has a secure development lifecycle. And you can see this online. This is their security development lifecycle, training requirements, design, and so forth. Each phase and the activities that are supposed to happen in each one of these areas. So EJ, why are you up here? We already know how to do this. It's been publicized. We're going to do this and our software is going to be secure. How many people have seen this? Never? Oh, this is going to be a good one. So these are the activities that are posted in the Microsoft Security Development Lifecycle. What you're supposed to do in each phase of the development lifecycle for software. I'm going to take you one step further. You can read about Microsoft's model and the activities that they do in that. And I'm going to take you one step further in addition to that, beyond these areas. So, the development activities. One thing to notice here with the secure development activities, I just wanted to put this chart up here so it's very apparent what we do for security to secure a system. Notice what I did here is I just put security before each one of the phases for the secure development lifecycle, right? So you gather requirements. That means you create secure requirements. Architecture, you create a secure architecture, and so on. Every phase you're doing security activities, which are they the same as the functional requirements for a system? Or are they different? Different, right? They're going to be different. And some of the activities that we're going to talk about are what you need to do, what you are going to be doing if you want to be an information security engineer or architect or analyst. These are the activities that you need to get better at and learn and be the authority in order to secure systems. Don't expect the guys learning system architecture to secure your systems. Don't expect it. And by that statement is the reason why many of our systems that we get from manufacturers are insecure. Because system architects are playing, I'm looking at Greg, are playing security, right? And so, anyway, that's the point of that slide. So what is the security in context here? The application security in context has 4 different areas to it. The first one is the supplier security. If your devices aren't secure, or the development practices of the supplier aren't secure, then all the activities in the world aren't going to make you secure. And we're seeing a lot of emphasis on supply chain security now, and so forth. Software security is another one. The Microsoft Development Lifecycle fits into software security, and you saw where we have some of the areas, authentication, authorization, and so forth, that need to be taken into account. Probably best way to look at that is the CIA, this confidentiality, integrity, availability, authentication, authorization, and auditing, CIA AAA. The activities that go into developing software security. Then there's also the network security, ensuring that your network gear is going to be secure. And one of the fundamental things here is that your network routing policies are configured properly and managed properly, configured and managed. And then there's the host security. A lot of people a lot of people put emphasis on patching, and that's important. And Microsoft's doing a great job, for instance, of securing their operating system. Great job. But a secure operating system isn't going to help you at all if your website has, cross-site scripting or SQL injection vulnerabilities, as you can just read, how all the passwords are being stolen out of websites and so forth. Any questions on that? Where's all this coming from? So there's some motivation for doing security, application security. The first one, legislation. In information security, do you study any of the legislation that's coming out? Yeah? Ryan does. Anybody else? Here's some of the legislation, just a tip of the iceberg. There's more legislation and regulations that point to the need for software security. One of the ones I'll point out here is the PCI, where the payment card industry has put together their data processing standards. And in my opinion, they've done a great job. They've given practical requirements for what systems need to do in order to keep them secure. Does it necessarily guarantee that those systems are secure? Your cardholder data is going to be secure? It doesn't necessarily mean that. And you can just look at some of the successful attacks to the payment card handlers that have occurred to know that PCI certification doesn't go what it needs to do, but at least it's a standard that has practicality to it, and people can have some good principles in order to apply and the requirements. Specifically in the PCI's requirement 6, and that is develop and maintain secure systems and application. So from the standpoint of regulations and legislation, at least if you're going to be processing credit card information, it's mandatory. So who's going to who in the company is going to be responsible for implementing these kind of requirements? Do you want to be? Very funny. Who's in information security? Who's graduating in information security? Okay, well, we got 3 volunteers. But the point is, it's going to be you guys who are responsible for it. Whoever, if you're going to be graduating information security and you want a job, and you come to me and say, I want a job in information security, I'm going to expect you to understand how to make things secure. Okay? Because of legislation. Then there's also the hackers. No need to talk about that. And reputation and the cost of being hacked as well. You guys probably can read all that stuff. So there's obstacles to application security as well. Executives or the owner of the company will say, we're not going to spend any money on application security. We need to get time to market. And you see this time and time again, where security requirements take a back seat to functionality. We've got to get this system in place. We have to make it, we have to get it out there. Let's fix the security problems later.
We'll patch it after.
Yeah, and patch later. Yeah, exactly. I've seen this countless number of times. What differentiates a good information security professional from a bad information security professional is the professional who can stand up and say, you're right. We'll go to market, but here are the risks, and then send off a encrypted email, or not encrypted, but a signed email that says, you know your risk now. That's the good one. The bad one just says, okay, see you later. Doesn't do anything. The risks need to be known. So return on investment for the owners of the company or the executives. Executive buy-off is super important as well. Making sure that your manager, their manager, and so forth understand it. Understand what the practices are going to be doing. So you're going for a job interview. Going to go for a job interview for information security. And they always say, do you have a question for us? And I never get a question. Do you have any question? No, I pretty much explained it. The question would be, who is the one that signs off on allowing, or the process for information security, or the application security, or system security, just fill in the type of security you're talking about. Who's the one paying for it? That's what you ask. And they'd say, you got to run, because you're not going to be successful in that. You got to have executive buy-off. Also, developer training is important. Attack environment is always changing. You must have good training. My guys are always going to training. Train. Sometimes it seems that's all they're doing and not doing any work, but that's a different problem. Security also treated as non-functional. Usability is a super important point. We were just having a conversation before we came here about wouldn't it be great if we could secure these devices so much that we had 100% security. My point was we'd be out of business. We wouldn't be doing business if we weren't able to accept some risk or some usability to the system. And so there's always this tension between the usability and security, and you have to understand where that is at. And there's just some, I'm not sure if you guys have the study of informatics, but how usable is security. It's a whole field of study. Security is challenging because you have many stakeholders to keep in mind. And this chart is just trying to explain that you have confidentiality, integrity, availability, and then internal to all that, you have a whole bunch of people telling you what their needs are. And so that's adequately said. A lot of people are coming to you for help. And sometimes it is difficult to understand who has the most priority and who's, how to help them. I guess that's the best way to put it. But anyway, some of the areas I've put up on here is who your customers are going to be, because I think a lot of people graduate from college and they think I'm going to work for my boss. In information security, you work for many different people. You're going to have a manager, but you're going to be dealing with literally everybody. Everybody's going to be knocking your door down. In fact, I just had a buddy who went to work at another organization, and he said to me the other day, EJ, I am like a life preserver in a drowning boat. He's not getting any work done. They're just coming. I need help in this area. I need help in this area. No, he's not getting any work done. So that's how he feels, or he understands this particular slide. So. All right. This chart is based on the Zachman framework, and it's a framework for system secure or architecture, security architecture. And so, once you get heavily into security, people start asking you, "What's your security architecture?" And so you describe your security architecture in this is one way of doing it in a 6x6 Zachman framework, where you have the who, what, when, where, why on the top, and then you have the different layers across the side. What I've done here is I've circled the different areas that in an enterprise architecture, security architecture, would be the areas as a security professional that you need to have some understanding of. Information classification, training and awareness, many different things. And can you spend a career in any one of these areas? Yeah. I mean, we have people at Boeing who spend their lives classifying data. And you think, how boring. But they like it, and that's what they do. We also have people who do database security. And I could talk for hours on each one of these bubbles, but I'm not going to. Anyway, so we have the training and so forth, and we have people who do the training and all that kind of stuff. So what I'm trying to demonstrate here is at each one of the layers, there's multiple disciplines that are necessary in order to round yourself out as a security professional. Many different areas that you can spend time with. Do any of these areas, you're probably studying some of these areas within your studies. Do any of them look familiar? Yeah.
Why and component is one I would think that many of these students are focusing on. Research vulnerabilities, threat research, vulnerability research, sort of type activities.
Oh yeah, right. And under the component, or under Y component, yeah. Lots of research. And that's what I mean, is you can spend your entire life doing research on components. But if you do, that's fine, but you see there's other areas that are necessary to secure the system. Other areas within security or information security in order to secure the system. It's just not one area. They all play together in order to secure the system. That's the reason why I put this
Certainly
chart up.
application security, administration management is the focus of it. So, a few nods.
Well, I'm glad you get the same response I do. Okay, so let me ask a question. What is application security? Yeah, go ahead. What is application security to you? Yeah.
Application security for me is to make sure that an application do what it has to do, but at the same time has the correct protection to avoid that someone else can manage the application and do something bad for the organization.
Excellent. Okay. Yeah. And so it is ensuring that the application does what it's going to do, and then that it cannot be misused by an attacker. That'd be a fair summary. Yeah. Anybody else? Do I want to point out anybody else? Application security. Okay. Yeah. Did you want to take a whack at it? Yeah. Have you practiced that one? Okay. Let's take a look at what ISO says in 27034. Yeah.
In slide 4, it shows that you mentioned that in company there are people that are specialized in specific things.
Get your mic.
But the question,
It's on.
It's on.
but the question is, what happens if those person quit tomorrow? So and you only have those people in charge of doing a specific homework, and you don't mix the responsibilities.
Oh yeah. Oh yeah. And not only that, let's see. The question is, if you have expertise in one area and then that person leaves, what is the state of your organization? And so, yeah, I mean, the famous example of that is a few years ago, the system admin for San Francisco wanted more money, and he ultimately quit and took the passcodes for many of the systems within San Francisco, and they were left. Anyways, it got really ugly. But anyway, they finally got the codes back. Here's a real life example. And so that is what we call in the what's the security principle of split duties, I guess. And so you always have to have somebody who's backing up another person. And that's more in the people area of security, to make sure that your availability is there. Does that answer your question? Yeah. And so from a management standpoint, from a security management standpoint, and the availability, you would be saying, why do we have an administrator who is maybe the only one who can log into the system, and B doesn't have a backup? And so some systems, you've seen the movies where they all have to put their key in and turn at the same time, and that's kind of split or dual responsibility. I can't exactly remember with the white lights on it, but in any case, there's a security principle along those lines. The important point up here is that you guys didn't mention is it's a process. You got to have a process for doing application security. And then another one from Wikipedia here is measures taken throughout the life cycle of the application. And so what these measures are doing is they're measuring the risk to you and the system, and what you're going to be doing with the system. So then there's also the NIST from 812. And this is saying whether the features of the system or application meet the security requirements and specifications. Has anybody No, maybe I'll ask later. But anyways, the important point here is it meets the security requirements and specifications. Okay, so far we got a process, we got measures, we got security, or the meets the security requirements and specification. Okay, and the last one is from CNSI, or CNSI 4009. The software assurance is and this is the famous one, the level of confidence the software is free from vulnerabilities. How do you get that level of confidence? So how, when your manager says to you, how do we know it's secure? And you go, well, we didn't find any bugs in the last 2 weeks, so we know it's secure. That's not the way that you provide assurance. You provide the assurance because you've used a process, you've measured it, and at the very end you're able to say, we're secure, or this is where we're not secure. This is our level of risk. So this is based on the V Lifecycle model. I'm not sure you study this or not, or maybe you do, but anyway, you're probably familiar with the waterfall method or the agile method. Well, this is the V Lifecycle model, and basically you got verification and validation on both legs. And so as you go down one leg, we're doing most of the implementation of the system. And as you go up the other leg of the system, you are verifying that system or validating that system is in place. And so just at a high level, you have the concept of operations. Super important. What's a concept? Anybody know what a concept of operation is? People, you probably don't know what it is, but you do use it all the time. And even in your personal life, you use it all the time. So here's a concept of operation. I'll give you an example, if I can think of one. Concept of operation. Well, so what I'm going to do is I'm going to create a new app. I'm an iPhone developer on the side, and I'm going to create a new app. And what the app is going to do is it is going to have some personal information in it and allow the user to type in. But what I'm going to do is I'm going to have, because I know that the device is going to be shared between family members. I mean, you all have your own devices, but some people don't. You know, they all share it between each other. And so I go, well, what I'll do is I'll put a password on it. And the password will be something like 4 characters, and it will be optional to put it on the app in case it's a single user device. What do you think of my concept? You like it? You don't like it? Go ahead. What do you think of it?
Doesn't seem very secure.
Well, it's not very secure, but at least I have given you the concept of how it's going to operate, and now you can tell me what you think. So you're saying it's not secure, and I say, well, your data is probably not really big deal, and so I'm only trying to get the ankle biters away from your system and not the determined attacker. Is that fair? Or you say, no, my data is super secret, and therefore I'm going to want to protect it real. Okay, so my concept is good or bad. You as the customer now can tell me if my concept is good or bad. This is the way that I start developing my requirements. Okay? And so I'm not spending any time, or not spending a lot of time, looking at the time, but I'm not spending a lot of effort in my concept. Okay? But I'm documenting it so, you, the customer, can tell me whether it's good or bad. What do you think? Well, personally, I think it's a good idea, and so does the government. They think it's a good idea to tell them how the security within their system is going to work. I can't tell. I could tell you, but I won't tell you how many times this has bit me in my career. Is not explaining what the concept of the security is going to be to a system, and then we get down to operation and maintenance, and somebody says. And we go right back to the drawing board. And now we're spending a lot more money. Okay? Requirements and architecture then would be the next thing after the concept. Once you say yes, we like it, then we start writing the requirements and designing the architecture. And you're probably more familiar with these areas, right? The requirements and architecture, detailed design. Does all that start sounding, especially the computer science students, right? That sounds familiar, right? Design. I asked you earlier what your favorite class was. Didn't get a single response. Now, this is going to be really easy. Is there a class about computer or software design? No. Here's a more filled out V model. That is a stripped down model that's built on the NIST 837, DICAP, NICAP, and the Information Assurance Technical Framework. Many of these areas are necessary in order to have the development of a system that you need to be familiar with, no matter where you're at. And you can see what the in yellow there. Is it yellow up there? Yeah, in yellow up there are the areas that you would need to do for having a secure system. That's the best way I can. That's the way I'll put it. So we have our security requirements. We have our threat modeling, and code scanning, and vulnerability and testing, and red team testing. And remember, I said earlier, everybody comes in my office and says they want to know how to hack the computer. All they want to do is start out at red team testing. That's where they want to start. Hopefully, at this point, I've convinced you that you don't start there. Hacking the software should be done last so that properly designed systems, your pen testers or those hackers that come into the system are going to be so bored that they're not going to want to do it if you've done your job right.
I have a question.
Yeah.
I don't have it's the microphone thing, but
I'll bring you one. You can.
what is the time frame for each category? Because you mentioned time, but like how do you determine an application secure, and how long does it take you to decide?
That's a really good question. So the question is, how long? What's the time frame for each one of these areas, and how do you know you're secure? Is that it? Many organizations don't follow a traditional life cycle. They use what is known as the agile method, and we use it at Boeing, and a lot of companies use the agile method. And the agile method is generally only as good as the project manager in the organization. I have some people that say we use the agile method. This doesn't happen at Boeing, of course. And I asked them, well, what is the agile method? Oh, well, we just start coding. And so in the agile method, you're still doing many of these phases throughout your sprints. Okay? You're still doing that. It's not like, okay, what we're going to do, well, you may do this, but we're going to have security month on our project and everybody's going to do security. No, what is necessary in many of the cases is, remember I had the dual stack there, is your security and security architect is going to be working hand in hand to ensure that the developers, no matter where they are at in the development phase, are working to ensure the system is secure. So, let me ask you, given that, now how long does it take? If you have embedded, knowledgeable security architects, you are stride for stride with the development team. In general. Does that answer your question?
Yeah.
Did I answer it good or bad?
Good answer.
Okay, yeah, I just answered it.
EJ, a traditional with many companies, when they're developing projects, software or whatever, is that there's a team that develops, and then hopefully before it goes to market, then they take a security review. Many of the things you're talking about. Is that, I'm picking up from this is not necessarily how Boeing does it, that you actually try to build security from the start of the project. I mean, do you assign a security architect to every project team, or how do you address these type of things? Or is security still thought of as an add-on after the product has semi-been developed?
Well, I would both. Oh, yeah, thanks. Both. You know, it really depends on the project manager, and it was so good of a softball that here I have the roles of what's necessary. And so when I was talking about answering your question about stride for stride, this is what I mean. Now, so we have security roles and then we have development roles. And hopefully some of these look familiar, at least in the development area, right? You got the program manager, the database designer, customer, architect, tester, developer, blah, 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 right? Security may not look so familiar, right? Designated approving authority, chief information security officer, information owner, and so forth. Anyways, I put these things in here. So, information security architect, the third one from the bottom. They all were working hand in hand with the system architect. This is important. Your system architect is not your information security architect. Because if they are the same person, what are you going to get?
Secure at this point.
Yeah, you're not going to have a secure system because always time to market is going to win. So if you go in there and you're asked to be, oh, okay, you're going to be the system architect. You know a lot about it. You went to Purdue. You're smart. You can do it. What you need to insist as a security professional is that you have segregation of duties. Very important, because if you don't have segregation of duties in your development area, you're not going to have security. You are not at the end of the or at the approving stage. You're not going to be able to provide the approving authority the assurance that the product is secure if you don't have your roles straight. Okay, you got to have your roles straightened out. Very important. I think I'm running out of time, aren't I? I got no.
You're fine.
Says I got 9 minutes left.
Yeah.
Okay.
Until they stop recording, but you've got another half hour.
Oh,
20 minutes.
oh, these guys look thrilled. Okay. Right. So the first thing is security requirements development. There's different ways of developing security requirements, and I'm often asked this question: is what are your security requirements? I love that question, by the way. It's like if I walked up to you just right now and said, "What are your security requirements?" Well, my security, I lock the door on my house, and I lock the door, I lock my bike up, and those kind of things. Those are your requirements? Well, really it depends on what the system is. First of all, right? You have to first of all, you got to tell me what the system is, and then I can tell you what the security requirements of the system are. Well, the system is there to protect, I don't know, all the money that I store, at the house. Oh, well, okay. Now we can give you your security requirements since we know what it is, or know what the system is supposed to do. Probably a bad example, but you get the idea. It's almost a trap. Is give me your security requirements first, and I'm not going to tell you what the system does. That's the reason why you have these split roles. You have one role as a system architect, and with the system architect, the security architect is developing those security requirements. There's different ways of classifying the type of data, and I put in some of the I put in here some of the different standards that can be used in order to identify and classify the data. And of course, I talked earlier about this concept of operation of the ConOps. So once we determine what type of data it is, now we can say whether the app 4-digit passcode is a good idea or a bad idea. Once we've talked about what kind of data it is. And so you can also see this is a DoD directive to ensure that you have the information assurance requirements. I'm going to just go back up to here to the roles. Who develops the information security requirements? Now, this couldn't be more of an open book exam or test pop quiz right now than anything that I've ever seen in college. Who's responsible for it?
Everyone, right?
Everyone. I was talking about the development. That's an interesting point. And you only get one answer. Or there only one person is. One person? Which one? There's only one person here responsible for the requirements. Or the development of the requirements, I guess. Right? Security architect working with the system architect. Is the system architect responsible for security requirements? Okay. How you develop security requirements, in addition, you go to your internal policies, regulations, which we looked at briefly, and then what the system needs are. These develop the system requirements. So, I put some examples here of what security requirements are. They may be really bad, but they're what the requirements of the system are. User and administrator activities must be authorized, logged, and monitored. Administrators must be strongly authenticated to the system. So those are security requirements. Depending on, I'm just giving some examples there. That's what security requirements look like. Now, depending on the system, you get a little more in detail. But I just wanted to give you an example that you create security requirements depending on what the system is, dependent upon the system. And so, if the system doesn't have users and all it has is administrators, obviously then administrators still the administrators. Or if you have other roles in it that you've identified early on in the system development. There's a security design principles also are necessary to be applied. At last count, there was 37 different security design principles. I'm like joking about that, but there are a lot of design principles. There are system design principles. There are software design principles. Well, and there's usability. There's a whole bunch of different types. Anyways, here's some secure design principles. You can see least privilege, separation of duties. Do you want me to go through each one of these things? Okay, never mind then. You can read. Anyways, this design principles are important because as the security architect or as the security officer, you're going to be looking at the design or influencing the design of the system given standard principles. Now, most people aren't familiar with design principles. Maybe a few of these things like least privilege. The system is not, anyways, no more privilege than is necessary, separation of duties. We already talked about that one. Those things seem kind of easy to do. But there's certainly others. There's a whole another page of them as well. Open design, this is the one where you use the, generally associated with the encryption algorithms. The design is open, and anyone can look at it to ensure that the algorithm is secure, and so forth. You apply design principles to your security design in order to implement a good design. So here's an example. You ever seen something like this as a design? Here's our we're a prototyping shop. Here's our first design. What do you think? You don't like this one? It's a good design, though. I mean, at least you got something. But I'm sure you've even done this. I've done it. I've developed iPhone apps. This is my design. Well, not that, but you put together a storyboard, and here's my design. Is that a good way to do design? Well, if you're a single guy and just putting in your iPhone apps, I can do it any way I want to. Not saying it's good or not. But if you're going to trying to be creating a secure system This would be not the right way to do it. This is not what a good design looks like. Good design looks something like this, where you have use cases, UML diagrams of sequence, class, and deployment diagrams. That's what makes up a good design. Now we can see from a security aspect of what is the timing sequences, what are the data flows, where is the data at rest. We can start securing the system. If all you get is the previous one, you don't have a very good design. We also use abuse cases or misuse cases. This is opposite of use cases, where use cases, what they're trying to do is show how the system gets used, actors and activities and so forth. What we're doing here in misuse cases is we're trying to break the system. How would we go about breaking the system? So what we're trying to do is we're trying to, early on in the life cycle, take the position of an attacker and start thinking of ways to compromise the system. How would we compromise this design of this system? And once we've gotten there, another technique is threat modeling. And threat modeling has a different, is basically the important point here is it's a process. And the process is to discover what the steps are that would what steps that an attacker would take, and how would we mitigate them. And we look and we model the application through a diagram, and through the diagram we identify threats, then we mitigate them, then we validate, but we keep going. Remember in the V diagram I showed you, the green one? You had threat modeling. You could really put threat modeling the whole way, because you're just continuing on every phase. You're always developing your threat model. Now, I earlier brought up Agile in response to a question. In your Agile process, it is super important that the security architect keeps this threat model up to date, because at any time, if the product is released, bam, you can say, here's our level of assurance. If it is deemed as just a one-time activity, then you're not going to be able to communicate that very well. So threat modeling, secure design choices, mitigate risk, and drives the test cases. Real quickly, here's some threat modeling process where Microsoft has a method of doing threat modeling, and there's other methods of threat modeling as well. What we're trying to do in threat modeling is find out where the data is at, and where it's flowing to, what processes are being used, and so forth. So it depends on where you are at in the life cycle of the system. If you're early on, you can do a high-level type of threat model to start addressing the threats earlier. And what I'm doing here is we're creating a physical topology and a logical topology, and then we start taking our threat modeling process and putting in instances of the type of protocols that are going to be used, the threats to the system, the users, and so forth. And so we start diagramming out where the threats would be in the threat modeling process. And with that information, what we do is we identify and rank what the threats are. There's different type of methodologies to look at. There's the OWASP method, there's FAIR, then there's the STRIDE and DREAD model, and also the Microsoft Bug Bar, in order to identify the threats. So this is a really bad example, but it's high level enough, to understand. What we do is we would say, okay, the threats to the system are cross-site scripting. What controls are we going to put in place? We're going to encode the output. We're going to validate requests or input validation. How would we rate cross-site scripting? We rate it high. Just a high-level example of what the threat mitigations would be. Once we've modeled it, now we're analyzing it and we're rating the threats. And this would be somewhat of an example of what threat mitigation would look like. So we can see SQL injection and so forth. Challenges to threat modeling. I think the biggest one is there's not very many people who are good at it. And threat modeling is big bang for the buck. Is you get the right mitigations in up front, you can save yourself a lot of money. What was the first chart I put up? The stack chart? How much you save in different phases? You can save a lot of money by doing threat modeling early on in the development process. Because once you find a vulnerability later on, some security guru like myself is going to come in and say, where's your threat model? You're going to go, oh, we did one about 3 years ago, and we haven't done one since, and that'll be the first thing that we go after is what is it? What's the current, design of the system? What are the controls are in place? What we need to do? How do we rank them? And how do we fix the system? That would be the first thing, and you get a lot. Anyway, that's the chief challenge to threat modeling, but there's some other ones up here as well. Some of the different type of software attacks are up here that you would be coding against. Injection flaws, cross-site scripting, and so forth. These are all found in the OWASP top 10. If you want to read more about them, and you can also read the CWE, the Common Weakness Enumeration, from. Okay, securing software. Once the code gets started, how do you go about ensuring that you have secure software? Anybody have any ideas? There's a few different ways, and they're up here. The first one is you run all the tools you can get your hands on onto the code. So you may not be the developer on the system, but you have to work with the developers in order to secure the system. What you want to ensure is that they're properly trained and that someone on the team understands good coding or secure coding practices. That gets to the training portion that I talked about earlier. And then running tools. Some of the tools are up here. There's other open source tools. There's a whole bunch of research tools out there that can be utilized. But tools only go so far. Sooner or later you have to get into code reviews or peer reviews to make sure somebody knowledgeable is looking at your code. So you'd say, well, did you have this area of the code looked at by, so-and-so? Oh, no, he was on vacation. I had, so-and-so do it. And, oh, well, so-and-so doesn't know anything about, C++ or Java or whatever. Oh, really? No wonder I made it through so easy. Something like that. The idea is knowledgeable people, assisting in the code reviews. And then there's also the training. Finally, the testing. So you want to hack computers? I've talked about this the whole time, or I've been talking about this a lot. Security tools are up here. Utilizing security tools to start cracking or start hacking into the software and doing your security testing to ensure that what you said you were going to do, you did. This is where you're trying to verify, validate, verify. Trying to verify what you did. And so there's some different type of security tools, and I have a quote there. A fool with a tool is still a fool. That means not accepting somebody who doesn't know the proper operation of a tool, or the tool is out of date, or a number of things that can go wrong with open source tools and the use of them within an organization. So in summary is up here some of the best practices and activities in each one of the phases of the development lifecycle. Requirements: classify your data, develop your security requirements, provide your risk analysis, and then in the activities, some of the activities that I talked about is up here as well. Yeah. Oh, okay. One thing I haven't talked about here is the incident response plan being developed in the testing. As a security professional, you're going to be asked to participate in disaster recovery plans or incident response. Don't roll your eyes at it, because when you're when you get a job at a bank, or you get a job, right, or you get a job at AT&T or something like that. I'm not saying, probably shouldn't have said that way, but if you get a job somewhere, there's a good chance you're going to get hacked. And you always have to have an incident response plan for a system before you get hacked. Because if you don't, somebody's going to say, well, how come you don't have an incident response plan? Oh, well, because I'm a really bad security person, and I don't really know what an incident response plan is. Very important to plan for an activity in the chain of communication and so forth before you get hacked. And other than that, that's it. Is there any questions? Okay, well, I appreciate your attendance, and thank you.